So we're all using AI these days, right? We see the magic happening on the screen, but if you ever stop to think about what's actually going on under the hood? Well, today, we're going to pull back the curtain on the unseen engine that makes this entire AI revolution possible. This is the hidden tech that makes the difference between a slow, clunky chatbot and the lightning-fast tools that are changing everything.
You know that feeling, don't you? You type in a question, you hit send, and then there's that pause. You can almost feel the gears turning somewhere out in the cloud. Well, that lag, that little thinking time, it's not just in your head. It points directly to the single biggest challenge holding back the entire world of artificial intelligence.
Okay, so let's put a name to what's happening in that pause. Every single time you ask an AI for anything, it's performing a process called LLM inference. LLM, of course, stands for large language model. And inference is just the fancy word for the model actually using its training to come up with a brand new answer for you. It's the thinking part, the doing part of AI.
And that right there is the core of the problem. Inference is incredibly difficult. It's not like running a simple app on your phone. It takes a colossal amount of computer power for every single request. For a service with millions of users, this creates a gigantic bottleneck that makes AI slow and super expensive to run at scale.
So how do the big players like OpenAI, Google, and Anthropic get around this? They can't just keep throwing more and more expensive chips at the problem. That just doesn't scale. The real solution, the secret weapon, is a highly specialized piece of software designed for one job: the inference engine.
The absolute best way to picture this is with a Formula One car. The AI model itself, all its data and architecture, that's like the sleek design and the chassis of the car. But the inference engine, oh, that's the hyper-optimized, custom-built F1 engine that takes that beautiful car and makes it perform at absolutely mind-bending speeds.
So, at the end of the day, here's what you need to remember. An inference engine is a software system built for one thing and one thing only: to run a trained AI model as fast and as efficiently as humanly possible. It is the unsung hero that makes real-time conversational AI a reality for all of us.
But how does it actually do it? How does it get these incredible speeds? Well, it's not magic. It's a collection of really brilliant engineering tricks. So let's dive into the 3 biggest tricks these engines use to squeeze every last drop of performance out of the hardware.
Trick number 1 is called quantization. Now, an AI model's brain is basically just a giant collection of numbers. The original model uses these very precise, complex numbers. What the inference engine does is cleverly convert them into much simpler, lower precision numbers. As you can see, this makes the memory footprint way smaller, and the math becomes dramatically faster, all without really losing the core accuracy of the model.
The perfect analogy for this is shorthand. Quantization is basically like switching from writing every single word out in longhand to using a super efficient shorthand. You're getting the exact same message across, but you're doing it in a fraction of the time and using way less paper.
Okay, trick number 2 is all about being smart and not doing the same work over and over again. It's a technique called KV caching. See, in a back-and-forth conversation with an AI, a lot of the context stays the same. So this technique creates a kind of smart memory, a cache, of the important calculations, so the model doesn't have to start from zero every single time you add to the conversation.
Here's how that actually plays out. When you ask your first question, the model does the heavy lifting, and it creates this KV cache of the context. But here's the genius part. When you ask a follow-up, instead of reprocessing that entire first question, it just grabs the context from its memory, from the cache, and focuses only on the new words you just typed. This saves a staggering amount of processing power.
And the third major trick is batching. This one is absolutely essential for any large-scale AI service. Instead of handling requests one by one, which is super inefficient and leaves the powerful GPU sitting around bored, the engine groups a bunch of requests together into a batch. Then it blasts that entire batch through the GPU all at once, running it at maximum capacity. This massively increases the number of people it can serve every second.
So we've seen how these things work, but who's actually building them? You might think it's just 1 or 2 big companies, but that's not the case at all. There is a whole universe of players out there, from the biggest names in tech to passionate open source coders, all pushing the limits of what's possible.
I mean, just look at the diversity here. You've got the tech giants like NVIDIA with their monster engine, TensorRT LLM. You've got fast-moving startups like Fireworks AI innovating like crazy. You have amazing open source projects like llama.cpp that anyone can use.
And even universities like UC Berkeley are creating state-of-the-art engines. Seriously, innovation is coming from every corner of the map.
Now, it's also really important to know they're not all built for the same job. You have two main types. You've got server engines like NVIDIA's, which are absolute beasts designed to run in giant data centers on thousands of GPUs. And then you have edge engines like Llama CPP, which are all about efficiency, designed to run powerful AI models right on your own laptop or even your smartphone. So, after all this deep dive into the tech, let's zoom back out and ask the big question: why? Why does all this speed matter so much? It turns out the answer affects everything from the future of business to what you can do on your own computer.
This obsession with speed and efficiency, it literally changes everything. It's what makes real-time voice assistance possible, where you can have a natural conversation without awkward pauses. It drastically lowers the cost of AI, so it's not just a toy for big tech. Small businesses and startups can build amazing things. It's the key to getting powerful AI running locally on your devices, no internet needed. At the end of the day, making AI faster and cheaper just accelerates the pace of innovation for everybody.
So what's the end game in all of this? What is all this incredible engineering really driving towards? The ultimate goal is simple but profound: to make the cost and the friction of using AI completely disappear. To make intelligence as instant, as abundant, and as reliable as flipping on a light switch.
And that leaves us with one final and pretty incredible question to think about. When these engines get so good, so efficient, that the cost of an idea, the cost of generating a new thought with AI gets close to zero, what will we build then? What becomes possible when intelligence itself is no longer a bottleneck? That's the future these unseen engines are building for us right now.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.